As Earth rotates, you see different parts of space. During the day, the side of the Earth you live on faces the sun. As this path turns away from the sun, it becomes night. The rotation of Earth changes day into night and night into day again. If you watch objects in the sky, such as the sun, they appear to rise in the east, move across the sky, and set in the west. What you are seeing is the apparent motion of these objects, not the real motion. Apparent motion is the way something appears to move. As Earth rotates from west to east, objects in the sky appear to move from the east to the west. Earth's rotation causes the apparent motion of many objects in space. How can patterns of apparent motion of the sun be described, predicted, and explained with models? This is night and day. Explaining a phenomenon that you cannot readily see and describe can be a challenge. This is especially true when your perspective may not be what is actually occurring. Think about a book sitting on your desk. From your perspective, it doesn't appear to be in motion. In actuality, to make one complete rotation in 24 hours, the book at a point near the equator of the Earth must move close to 1,000 miles per hour. The speed gets less as you move north, but it's still a good clip throughout the United States. Because gravity holds us tight to the surface of our planet, we move with the Earth and don't notice its rotation in everyday life. In this activity, you will create a model of the sun and the Earth to better understand and be able to describe the phenomenon of night and day. All right, for your night and day activity, what you're going to need for setup is all here, so let's go over it. You are going to need a globe. You could also use a beach ball. It doesn't necessarily have to be the globe. What I like is I was able just to kind of pop this out of its stand, and the equator is already here. Everything you need in terms of understanding how to tilt this, it's pretty easy to do with a globe. Again, you can use a beach ball or even a styrofoam ball. Those will work. You're going to need a measuring device. Today I have a meter stick, but you could also use measuring tape, something that's going to get at least 1 meter. I have 2 index cards that I have labeled east and west, some masking tape. You're also going to need a source for the sun. So in this case, I'm using a lamp clamp, and I'm using an incandescent bulb today, so just be aware, guys, this gets really, really hot, so make sure not to touch this or these sides. You can hold it from the side here. For this activity, since we're going to be measuring light intensity, if you don't have this sort of setup, that's fine. You could also use a utility flashlight. And last but not least, you are going to need the light sensor. So there's 2 different measurements here. We have the spotlight. For this activity, you're going to be using the ambient portion of your sensor, and of course, access to the SparkView software. All right, gang, let's get started with data collection. For your first run, I am going to mimic an Earth model, and I am going to put east and west on the front of me. This will make sense in a second. I have my son here helping me out. This is my colleague Barbara, just out of camera view there. She will be the sun today. And we're using the measuring stick or measuring tape if you have it, because you want to be 1 meter away. Again, the Earth model wants to be 1 meter away from the sun model. All right, so I'm going to go ahead and put east and west. I need to put west on my right-hand side, because remember, we talked about apparent motion versus actual motion, and east on my left-hand side. All right. And this is important because I am going to rotate counterclockwise as we collect this data. Let me show you how to connect your sensor, because remember, we're using the ambient and not the spotlight. So I'm going to choose sensor data, and I want a luminescence marked off for ambient light sensor, and then I'm going to disable the spotlight. And I am going to create a graph of the luminescence over time. When you do this in your classrooms, it's good if you can dim the room. So let's go ahead and dim our classroom so you can see how this works. I am going to hold the light sensor at my waist level and start by facing away from the sun. Then I'm going to rotate counterclockwise 3 times. All right, let's get started. That's my first rotation. All right, one more. You should notice how I'm moving at a pretty slow pace. All right, I'm going to stop collecting data now. All right, thank you very much, Barbara, for helping me out. You can go ahead and turn the light back on. And let's get set up for the next activity. Thank you, Barbara. Okay, I'm going to take off my east and west and put those off to the side. And you want to do this ideally with a partner, but for this demonstration, I'm just going to go ahead and use this lamp clamp on a stand. And again, I want to measure 1 meter away, and this is where you're going to bring in your globe. So how do you stick the light sensor onto your globe? So you want some masking tape, and you want to put your light sensor halfway between the equator, there we go, and the North Pole up here. So I'm going to put it right about here, tape her down. Okay, so there you see I got it taped about halfway between the equator and the North Pole. We're going to do 3 runs here. I'm going to set my globe at the very end here. Go ahead and turn on the light. I'm going to dim the lights in the room again so you get a good view. And we're picking up only on the ambient light from the sun. Okay, for the first run, you want your globe just to be upright so the sun is facing directly at the equator. The next run, you're going to tilt the northern hemisphere 23.5 degrees so it is facing away from the sun. And then the final run, we're going to tilt it back the other way and now have the northern hemisphere facing the sun. All right, let's start collecting data. I'm going to rotate my globe 3 times counterclockwise for each run. All right, directly on the equator. Here's rotation 2. And 3. All right, stop collecting data. Next one, I'm going to face again, northern hemisphere away from the sun. Maybe you can already guess what season we might be in here. Start collecting data and then rotate 3 times again. There's 2. You really want to make sure you're paying attention here because it's easy to start tilting it the other way. So just make sure it's tilted away from the sun. Okay, 1 more run, facing towards the sun. Okay. See, even I had to think about that for a second. And start collecting data. There's 1, 2, and 3. All right, so now you have all 4 runs of data. All right, so in your data analysis collection, we have everything we need, but there's something really important that I want to make sure you know to do. Remember, we had 4 runs today. We had one where I was the Earth model, and I rotated 3 times. Then we did 3 runs from the table here, from the equator point of view, facing away from the sun and facing towards the sun, the northern hemisphere. I want you to rename these runs, so if you have to, I don't know, class is ending and you need to come back and check your data later, I want you to be able to access it. All right, so I saved my program, and let's look at run 1. And I'm isolating this because you're going to have questions that are specific to run 1. So let's rename this. You're going to click on the tools here, Manage Runs, and then choose Run to rename. And this one, I'm going to just put Human Earth Model. All right, so now you see in the key up here on the right that it's easy to decipher what this was. Now let's look at run 2. Same thing, Experiment Tools, Manage Runs, choose Run to rename. I want to do run 2. And there's different ways you can do this. I'm just going to say sun facing equator. Okay, 2 more to rename. So let's look at run 3. This was when the northern hemisphere was facing away. Manage Runs, choose to rename, and let's just do NH for northern hemisphere away from sun, which means now for run 4, I can say northern hemisphere facing sun. All right, so now that you have those renamed, it'll be really easy for you to pick which graphs you need to focus on. I suggest looking at the Human Earth model on its own. Once you've answered those questions, then select run 2, 3, and 4 so you can get a good comparison between each run. Okay, so between the information you got at the beginning of this activity and all of your light intensity data, you can now go forth and answer those questions in your student activity sheet.